Everybody, and welcome back to another fun and exciting pre-algebra class. Today we're going to be launching into chapter number 10. Here's the good news. You only have 3 chapters left. You have chapter 10, chapter 11, and chapter 12, and then you'll be done with this book. You'll be done with the 8th grade material from this year. So keep working hard, keep doing your best. Don't give up. Okay, we've got some hard chapters coming up. Maybe last chapter you really enjoyed because it was kind of a break from the algebra and different things like geometry that we've been doing. But chapter 10, we're diving back into algebra. So take out your book there. Let's look at page 474. Page 474. We're going to be talking today about polynomial arithmetic. Ooh, that sounds hard, right? No, it's not too bad. Really, today's lesson is about exponents, and specifically how to multiply exponents and how to divide exponents. Now, we've already talked a little bit, if you look down here at the screen, we've already talked a little bit about like terms. I know you've got to think way back in the book. That was chapter number 3 that we talked about like terms. But so let's review just a little bit. What is a like term? When do we use like terms? And then we can kind of move on with the lesson. A like term is something that is exactly the same. Well, I say exactly the same, and then it's not exactly the same. But what do I mean by that? It has the same letter, right? So you're looking right here, must have the same letter and the same exponent. For example, x squared is a like term with x squared. Those are like terms. Now, what if it's x squared and x cubed? Those are not like terms. Why not? Because they both have to be same letter and same exponent. When I said it doesn't have to be exactly the same, we could have different numbers out front. Like we could have this one could be 3x squared and this one could be 2x squared. Those are still like terms. Why? Because the letter's the same and the exponent is the same. That's what makes it a like term. Letter the same and exponent the same. Very important that you remember that. Okay, so now take a look at this next line. It says when adding and subtracting exponents, you must have like terms. So if you remember this from, again, going back to lesson number 3, chapter number 3, way back, we had this. We had something like 3x squared plus 2x squared. And we can combine those, right? Why can we combine those? Because the letter is the same and the exponent is the same. So all you had to do is you had to say 3 plus 2 equals 5x squared. This doesn't change when you're adding and subtracting. So if we have something like this, 3x squared plus 2x cubed, we cannot do anything there. We cannot add those together. Why not? Because the letter is the same, so you say, why can't I add those together? I should be able to add those together. But the exponent is not the same. These are not like terms. It's very important that you remember that. Now, go ahead and look down here at the next kind of little note that I put. However, when you multiply and divide exponents, the exponents can be different. You only need like bases. Okay, so let's go back. Let's go to this one right here. Let's say instead of adding these two, I'm actually multiplying these two. So let's say that I have x squared times x cubed. Look here, it says when multiplying and dividing exponents, the exponents can be different. Okay, look, I have a 3 and a 2. It's okay. We're still fine because we're multiplying. This is a multiplication sign in algebra. It only needs to have like bases. What is the base? X is our base. Guess what? X and X are like bases, so that's good. We can take this and we can multiply this. Now, how do you multiply it? Some of you might be thinking, well, I just take 2 times 3, so that's going to equal x to the 6th. That is wrong. That is not how you multiply exponents. So you're like, Mr. Steve, how do you multiply exponents then? You just blew my mind. I don't understand. Well, let's take a look. It's called the product rule. In the product rule, you simply add the exponents. You're like, wait, what? You're blowing my mind here, Mr. Steve. What's going on? To multiply exponents, simply add the exponents. You just need to memorize that rule. You just need to apply that rule. Stop trying to make things make sense in algebra, because guess what? They don't sometimes. They just kind of don't make any sense in your mind. You're like, what is going on? You don't have to know what's going on at this very moment. You're going to learn what's going on as we continue through the course, but you have to learn the rule. You have to learn, okay, what is the rule, and then follow the rule. So here's the rule. When you're multiplying exponents, simply add the exponents. What does that mean? Let's take a look right here. Y squared times y to the fourth equals y to the 2 plus 4 equals 6. Okay, now let me show you why. Okay, now some of you like to know why, so I'm going to show you the why behind this. Let's write y squared not using an exponent. So y squared not using an exponent is y times y. Okay, that's y squared, y times y. Now we're going to write our multiplication sign, and now we're going to write y to the fourth without an exponent. Y times y times y times y. Okay, so this is y squared, and this is y to the fourth. Okay, y squared times y to the fourth, right? So now check this out. Let's go ahead and erase this, and let's take a look at what we have. What do we have right here? What does that equal? That equals y to the 1, 2, 3, 4, 5, 6. Y to the 6th. That's why we add when we do exponents. Because when you actually write it out, when you actually write out what it is using times signs instead of the exponents, you will find that you're adding, you're not technically multiplying the exponents. All right, let's try it again. Now we have p to the 7th, p to the 4th, and p. Now, you might think, okay, I'm supposed to add the exponents. So 7 plus 4 gives me p to the 11th, and then there's not an exponent there, so p to the 11th. Wrong. You're like, oh no, not again. You're blowing my mind again. Okay, let's think through this. What do we have right here? This is not p to the 0 power. Remember that everything has an exponent of 1. Even when we don't write it, the exponent is 1. It's not 0. It's exponent 1. So now let's add them together. 7 plus 4 is 11, plus 1 is p to the 12th. The answer here would be p to the 12th. And if you want to look in your book, that's on page 475. That is example 10.1a. Okay? All right, next. We have this one down here, and we have, and this one's kind of interesting, right? Because we kind of have a repeat, and we have different letters. So what's going on here? Well, just take it, and remember, let's kind of go back to the explanation. When you are multiplying and dividing exponents, look, you only need like bases. You do need like bases. So for example, right here, I have different bases, like the n's are one base, and then the m is a different base. So I have two different bases going on here. Here's what you can do. You can multiply the n's together, and then you can multiply the m's together. So let's multiply the n's. N, remember this is a 1. 1 plus 3 equals 4. N to the 4th times m squared. There's nothing else to add to the m, so it's just m squared. Now, you could say that that's the correct answer right there, but typically in algebra, we always write things alphabetically. So we would switch that around, and we'd say m squared n to the 4th, and that would be the best answer that we could give for that question. Next, this is what's called the quotient rule. Well, what's a quotient, first of all? A quotient is the answer to a division problem. Okay, you should remember that from arithmetic. The quotient is the answer to a division problem. So now what are we talking about with quotient rules? We're talking about division problems. To divide exponents, what do you do? To divide exponents, you simply subtract the exponents. Notice now we're subtracting. What did we do when we were doing multiplication? We added. What do we do when we're doing division? We subtract. Okay? Now, here's kind of another little fun fact, I guess, if you will. If your exponent on the top is bigger, for instance here the 6 is bigger than the 2, your answer, your solution is going to be in the numerator because it was bigger. If you're, let's say you have like y2 over y6, here your answer is going to be in the denominator because your denominator was bigger. That's the easiest way to explain it. Your book kind of shows you a different way. I'm not really ready to show you that way quite yet. I think it's just easier kind of to take it. If the numerator's bigger, answer goes in the numerator. If the denominator's bigger, the answer goes in the denominator. So let's try that and see what happens. Y to the 6th over y squared. What should we do? We subtract. 6 minus 2 equals y to the 4th over 1. Why do you, what, Mr. Steve, why is it over 1? Well, let's check this out. Let's actually do one of these. Let's write it out. Y times y times y times y times y. Let me write one more over here, times y. Okay, there's 6 of them, over y times y. Now watch what happens when we're canceling, right? We're basically just reducing our fraction. What if we had 2 over 4? We reduce that fraction, right? By dividing 2 into both of those, right? And we get 1/2. You've been reducing fractions for a long time. So really what we're doing on this one is we're reducing our fraction. Watch what happens. We divide y by y, we get cancel, cancel. Now, when I say we get a cancel and a cancel, technically here's what we get. We get y divided into y gives us 1. So if you watch, what actually happens is we get a 1 and a 1. We divide and divide again, we get a 1 and a 1 again. Notice that we have a multiply here. So what do we get on the top? We get y to the 4th. There's y to the 4th. And then what do we get down here on the bottom? 1 times 1 is 1. There's our 1. Okay? So when you cancel fractions, it's not just like they just cancel and go away and disappear. They cancel to a 1. Okay? Anything divided by itself always gives you 1. So what we have is we have our answer is y to the 4th over 1. But we wouldn't write it that way. We don't write 3 over 1 as our answer, do we, right? So what if we get 3 over 1? We just write 3. So in this, we don't have to write the 1. We would just write that would equal y to the 4th. That's how we would write that. That's it. Now, let's take a look at this one. Same thing going on here that we've kind of done in the past with the multiplication. Now we have b, and there's no other b. So guess what? B just stands alone. B can't reduce. It can't, nothing. So we just kind of write b to the 4th over here. And that's a numerator. Now we look at these ones, and we have c to the 8, and that's the bigger one. So we know our c is going to stay up here. And so we cancel this by subtracting. 8 minus 4 is 4. So c to the 4th, and that cancels to a 1 over 1, or b to the 4th, c to the 4th. You might be thinking right now, Mr. Steve, why do you keep writing the 1 right there? That doesn't make any sense. It does make sense, and I'm going to show you why it makes sense. Why am I actually writing it and then canceling it and writing it again? Why am I doing that? Because the 1 is important sometimes. Now, it's not when it's a denominator. You don't necessarily have to write it if it's a denominator. But sometimes it is important. Check this out. What happens here? Well, we have, wait a second. We have 3 minus 3 equals 0. So this equals 0. No. Okay. Here's what happens. Remember what I told you. when we have 3 divided by 3, right? We get 3 divided by 3, it equals 1. Anything over itself always equals 1. So when we get this, we get a cancel to a 1 and a cancel to a 1, or we get 1 over 1, or we get 1 is our solution. So be careful when you are doing your subtraction that you don't just say, oh, 3 minus 3 equals 0, so my answer is 0. No, it's not. Remember when I told you that it always cancels to a 1. That's very important to remember. Last one that we'll do for this video right here is A3 over A5. A3 over A5. So now, watch what happens. Remember when I told you that you're going to want to keep it in the bigger, whichever's bigger. Is the denominator bigger or is the numerator bigger? When we do our subtraction, we would do 5 minus 3 equals, we would get on the top, this one is going to cancel to a 1, and this one is going to cancel to a 5 minus 3 equals a squared. Our answer is 1 over a squared. Now notice, that 1 is very important because there's a big difference between 1 over 2 and just saying 1 over 2 does not equal 2. That's wrong, okay? So the 1 is important. When the 1 is the numerator, it's very important that you keep it as the numerator. If 1 is the denominator, then you can get rid of it. But when 1 is the numerator, you have to keep it. Very, very important concept right there. So there's lots of stuff to practice right there for you, okay? So go back into your book, take a look at those practice problems, work through those. If you get stuck, rewind this video, kind of watch those different little pieces again. Maybe you're forgetting about what to do if it's the same, what to do if the denominator is bigger than the numerator, all those different things that are going on. Slide that video back, watch it again if you get stuck on your practice problems, okay? That's all I got for you. Hope you have a good one. We'll see you later. Bye-bye.